Let's look at some very interesting questions together about logarithms, and let's answer if each one of those is true or false. So our focus is on answering the questions and see if they are true or false for each one of those. So the first question is logarithmic functions have a vertical asymptote. Is that true? Well, that's a very good question, and it can be answered in many different ways. Do we know anything about exponential functions? Assume that you have f of x equals to 2x. We already know that the inverse of this function is the logarithm of x with base 2. We know that. We have seen that already. Okay, so the question is, what do we know about this function? It's an exponential function. Well, we know that the exponential functions always have horizontal asymptotes. And what are their horizontal asymptotes? Well, the horizontal asymptotes are at the point of the constant. So if you have the function and you have a constant right here, you do have a constant, right? It doesn't show, it hides itself, but there is a constant, is the 0. It gives us a horizontal asymptote that is y equals to 0. Well, remember, the logarithmic function is nothing else than the inverse of an exponential function. By inversing a function, what we do is that we exchange the x and the y's. What do we do? When do we do that? Well, if a point x, y belongs to the curve of the exponential function, then the point y, x belongs to the inverse. This is what we do. We take the table and we inverse the points in order to graph them, correct? Okay, and this is the same not only for the points, but for every other aspect of the function, of the curve, that has to do with y's and x's. So if the horizontal asymptote is y equals to 0 for that, then for the inverse, the vertical asymptote will be x equals to 0. What does this tell us? This tells us that since we know that every exponential function has a horizontal asymptote, then we do know that every logarithmic function has a vertical asymptote. So the answer here is yes. Also, we may remember that in general, the format of the log of x for any base a, it's going to look like this. It's a slowly increasing function that is asymptotic to the y equals 0. So the vertical asymptote for the logarithm function is x equals 0. Okay. Let's look at the second question. What is this? What does this say? What is the logarithm of a to the a with base a? Too many a's here. Okay, let's put them together. Let's see what can we use in order to solve this problem easily. Don't get confused, things are simple. What is the power rule? The power rule tells us that if in the argument of the logarithm we have an exponent, and we do have an exponent here, then the result will be that we will multiply the logarithm with that exponent. So if we have LA of x to the k, this is what the power rule says, then this is nothing else than k times the log of base a of x, I'm sorry. Okay, so following that power rule in order to solve this problem, it tells me nothing else than a times log with base a of a. Now we also know that the log with base a of a is nothing else than 1. Why? Because a then has no exponent, so we can assume that the exponent here is 1, right? Doesn't change anything. A to the first and is the same as a. Okay, so the log of that is 1. So coming back to our equation, to our expression, this is going to be nothing else than a times 1. So the answer is a. So yes, the answer for the second question is yes. Actually, what I want you to memorize from now on, to remember from now on, is that in general, this is considered one of the rules of the logarithms. Now, the next question that we have right here is log of a divided by log of b. Is it the same as log of a minus log of b? Let me remind you the quotient rule. Well, the quotient rule tells us the following thing. The log with any base, let's call it small a, of a fraction, let's say a over b, is equal to the log with base a of a minus to the log with base a of b. Okay, what I want you to see right here is the difference between this expression that we have right here and this expression that we have right here. Here we divide logs. Right here, we divide numbers inside the argument of logs. This is not the same with this. So the quotient rule doesn't apply here. Still though, we don't know yet if this is true. It is possible that this is true. So we want to find a counterexample. We want to show that if this is true or not. So let's try some numbers. Okay, I wrote here an example for you. What I tried to do is to use some numbers that they are numbers that you already know and you have worked with, and let's assume that the base of our logarithm is 10, that is simple to use and also to verify with a calculator if you want. Log with base 10 of 10 squared. What is it? Well, I already have right here my exponent, so the log with base 10 of 10 squared will be 2. Log with base 10 of 10 to the 5th. What is this? Nothing else than 5. So if I consider the log of a right here over log of b that I started with specific numbers a to be 10 squared and b to be 10 to the 5th, then this is what I get. 2 over 5. That is nothing else than a 0.4. It's just a number. Okay, now let's look at this. We want to identify, we want to decide if this is equal to that. Let's see, are they equal when the a is 10 squared and b is 10 to the 5th? Well, log of a in this case will be log of 10 squared. Log of b in this case will be log of 10 to the 5th. Well, log of 10 squared is 2. Log of 10 to the 5th is 5. So what I have is 2 minus 5. So in this case, the result that I get from this process is nothing else than negative 3. Well, what do you have to do now is to consider and actually compare the two numbers that you got. 2 over 5 in the first case, negative 3 in the second case. Are they the same? No, they are not. So immediately what you found is an example, or I should say a counterexample, that shows us that this is not equal to this expression. So the answer for this problem is no. Now the next problem asks us what the quantities log with base 2 of 1 and log with base 3 of 1. Are they the same? Well, we know that there is a rule that tells us that if I have a log with base a of 1, the result for that is 0. Why? Because 1 is the result of every number, no matter what the number is, to the 0 power. This is the same as 2 to the 0. This is the same as 3 to the 0. This is the same as 11 to the 0. It doesn't matter what is the base. To the 0 will give you the number 1. So log with base a of 1 is equal to 0. Okay, so let's say, what is this? Oh, the argument here is 1. So this is going to be nothing else than 0. What is this? Log with base 3 of 1. This is equal to 0 as well. So the answer for this problem is nothing else than yes, these two are the same. And we are looking now at the last problem. The last problem asks us, is ln of a minus ln of b equals to ln of a minus b? Well, remember that ln is nothing else than the logarithm with base e, but we never write it like that. The correct notation is ln. Okay, so we have to find out, is there a rule for the logarithms that tells me that if I subtract two logarithms, the result will be the logarithm of their difference? What this basically tells me, what I know, is the rule of quotient. Remember the rule of quotient. What does it say? The rule of quotient, and especially if we apply it to ln, it will give us nothing else than ln of a over b equal to ln of a minus ln of b. So this is what we know. This quantity, ln of a minus ln of b, will be equal to the ln of a over b. Now look at what you have right here. You have the ln of a minus ln of b. But right here, we are asked if this is equal to ln of a minus b inside the argument. Well, look at this. Is this the same like this? No, it's not. So the answer for that is no. Now, how do I know that a minus b is not equal to a over b? What are the a's and the b's? Well, in order for this equality right here to hold, it should hold for any numbers a's and b's. Any number. And for sure, we know that the difference of two numbers is never the same as the quotient of two numbers. That's why our answer is no. So we have the answers for each one of these interesting questions about logarithms.